Hello, everyone. Welcome to another binary episode of the Day Zero podcast. I'm Spectre. With me is C. Today we have some topics on the Anker Eufy Homebase 2 from Talos, a post about using CodeQL and finding a vulnerability in Accel-PPP, and a Pwn2Own post, or rather a post about a exploit that was submitted to Pwn2Own by Dory. Before we get into any of that, though, we'll get into the Spot the Vuln solution. As always, I'll pass it off to C here.
Yeah, and this week's Spot the Vuln, not a whole lot for it to hide within. Like, there aren't a whole lot of options for what could possibly go wrong here. I define a few structures up at the top. I've got a macro there, clear, that just does a mem set of 0 over the size of the structure given. And then we allocate a package structure using size of header and size of ops. The package structure just has two inline header and ops structures. And then, of course, clear ends up calling on struct packet. The problem here being, while even though packet just contains those two structures, and I think in real code you would probably see a lot more processing, a lot more going on between these two lines of code that can create this disconnect. And the allocation itself is a little bit of a odd one when you're casting it right into the packet. Why aren't you just allocating the right size base there? So actually seeing this introduced in code is going to be a lot more subtle than how I've written it. But the core problem is, even though the package structure simply contains that those two structures, because those structures aren't of nice, convenient binary round sizes, like the ops would come out to being 3 bytes, they're going to get aligned by default. You can compilers will support giving attributes, they get packed, but they're going to get aligned, so the actual size of packet is going to be larger than the sum of its contents. Which means that clear call, so the mem set using size of packet, is actually going to be larger than the size that was allocated for it. Potentially reading over, or out of bounds. Or writing out of bounds, sorry, when it does the clear. Somebody else called out in our Discord about the clear potentially being optimized out. That's another case, like mem sets with 0. It's more common with crypto code where that's actually a concern, where you want to zero out like keys that are being loaded. But I mean, there's not much going on here, so it's fair to at least call that out as a potential thing, especially if you have a clear macro, probably using it for a reason, and that could definitely be, or potentially be, optimized out here.
Yeah, I mean, if you have really aggressive optimization, technically this program will just optimize to a return 0 because
Not doing
you're
anything, yeah.
you're not using the memory at all. You're just writing it. There was a bit of a discussion about that in the Discord, but yeah, for the intents of the challenges, just assume 0. You know, wasn't really trying to worry about like the optimization too much there, but
Yeah, with the
yeah, it's
challenges, I don't like adding in a lot of excess. I'll be honest, this week I was just late doing the challenge, so I needed something quickly. But with a lot of, I don't like adding in a lot of code to make it more realistic. I'd rather just keep the code, it's only up there for like 5 to 10 minutes, so you don't have that long to solve it.
yeah. And this specific challenge is a little bit far-fetched in the way that, like, if you were allocating for the packet structure, you would just allocate the size of the packet, which would take into account the padding and everything. That said, these kinds of bugs do definitely exist in real code bases. A lot of the time you'll see that is if there's, like, you'll have leaks through the padding. So if there's some kind of structure that gets copied around, the padding obviously, if the structure isn't initialized to 0, and the fields are only initialized, then the padding is obviously going to be left uninitialized, and that could leak some data. So yeah, that's the most common form you see this, but yeah.
Yeah, there are different ways the padding can start to bite you when it comes to having these vulnerabilities. Like I said, this particular code, I agree, isn't. It would be very odd to see it, like, especially that allocation. But it does happen from time to time where people will allocate things. More often than not, it'll be out of like legacy code, where say an array is maybe getting turned into like a proper structure or something. And then they kind of copy in and out some code. That's where I've seen it a couple times. It's not the most common thing, but being aware of the structure padding, I think, is important. Like I said, there are other bugs that come from padding too.
All right, so we'll jump into our first topic, which is a Talos report on the Anker Eufy Homebase 2, which is their base for their Eufy security cameras, and they've got kind of like a full smart home ecosystem going on there. As you can imagine, this device does a fair amount of networking, which is what Talos looked at here. They looked at the libxmav library, which creates the network servers. In particular, they looked at the Wi-Fi com receive PTH server for this vulnerability, which had a buffer overflow in DemuxCmdInBuffer, which is called by the Wi-Fi com REST client PTH handler. What's going on there is the receive function just keeps reading packets into a fixed size buffer of hex 400 bytes, and then it passes that buffer into this DemuxCmdInBuffer function, which then does further parsing. In that function, if they match a certain magic inside of the packet, I think it's like hex FF005555, they take a user controlled size field, add hex B to it, and then add that to the number of bytes read so far. And that can be overflowed due to the unchecked addition going on there. Just pretty straightforward in overflow. That then gets passed to Wi-Fi command rest proc. They say that function doesn't do too much with the data len field though. It's only really used in the context of the check and potentially as a length and an fwrite call. They were able to push it to end up trying to read unmapped memory by just advancing the read pointer a bunch. But that just yields a denial of service. It doesn't really seem like there's any interesting exploitation primitives you can get out of here to do a more interesting exploit, but uh, yeah, I mean, still, when you're talking about something like a security system, a denial of service is definitely still worth keeping in mind and shouldn't be brushed off. So,
Yeah, I mean, it is also one of those things. It's a code smell. Like, sure, you have this, but is it likely they're using a similar pattern elsewhere? I would imagine so. Um, but yeah, they only really got with crash, and specifically, if the crash happens too many times, the device itself will reboot. Um, so it's a denial of service while being attacked, which is worth keeping in mind. Like, it's not necessarily a permanent denial of service, and it does require that kind of consistent re-attack. Kind of even limits its usage even further.
yeah, that's true. So yeah, it's not a super practical attack, but like Z said, it's a bit of a code smell, and considering such a low hanging fruit bug could be found here, it's probably exists in other places as well, and might exist in a more useful context for uh, an attack.
Yeah, and it's really keeping with the theme of the episode. Our next several bugs are going to be continuations on this integer overflow aspect.
Pretty much all of them. Yeah. So we'll get into our next one here, which is a post by Chloe Ong on finding bugs in Accel-PPP, which is an open source VPN server. And I'll let Z get into this one.
Yeah, and this one, like I kind of just hinted at, the vulnerabilities here, pretty straightforward, are integer overflows. Got allocations where they'll add something. Um, so the post does start off talking about using CodeQL to find these vulnerabilities. Um, Sorry, just trying to scroll to one case, but they're basically, I believe they came across basically 3 cases where you have this potential overflow of trusting a length. Sorry, I've described this as an integer overflow, but now I think about it, that's the next post is more closely related to the integer overflow. This one is a bit more on just the untrusted value being used into a mem copy. Apologies for misleading everybody really quickly with that. But yeah, so in this case, it's basically packet comes in, read a length from the packet, perhaps add a value to it to move the buffer along or whatever, but ultimately trusting the value that they're reading out of the packet, passing it into a mem copy, which of course, without doing any bounce checking on that length, overflows whatever the destination buffer was. That happens in like 3 different cases here. 2 of them, I believe, were reading into this attribute and then like some value in there, and then the other one was in, was it some sort of like telnet code? It's towards the end here where they have the command line length that also Same issue, trusting the length, reading it into the buffer. I will call out, they do spend a little bit of time talking at the start about the CodeQL queries that were used to kind of find these vulnerabilities, starting off with just the idea of let's find all the places that lead into that memcopy argument, or sorry, places an attacker could control that lead into the memcopy argument, that lead to controlling the size, and then just check those for vulnerabilities. Covers kind of their flow, I guess, for creating these. Has a little bit of insight into how you need to think about the queries when you're writing, at least for the taint tracking queries. Because what you do is you write a configuration query basically that does two key things. That there's one query that matches all of the sources that you want to follow, that you want to use as a source for the taint tracking, and one that'll track or match all of the syncs. Similarly, all the places you want to go, and then you let it find all the flow between them. They work through a few problems, did a little bit of variant analysis once they found an actual issue there. I do believe that their very first query doesn't actually do what they intended it to do. And that's part of why they weren't matching what they expected. So for anybody who kind of comes into this, what I believe might be happening in the first query, I'm just scrolling to it here, is that they write this is source, and that's being written as source, as expression, function call. So they're typecasting into a function call. Parent is from source. Actually, this is the second query, but first query function called get target has global name received from. They ran this a couple times with other functions they cared about. The issue I believe with this is that's matching as a source the actual function call, whereas something like receive from, it takes an argument with the buffer that they care about. The return value is going to be like the number of bytes received. So what this is matching is it's matching that function call itself as the taint step rather than the argument inside. So there's another function as defining argument that I believe you'd want to use to actually track the buffer passed into receive from and track that as being tainted by this call and then where it flows into. But they do raise another reason why, even if you wrote that query properly, it basically wouldn't end up matching because the actual code is a little bit weird in terms of its order. They have this pointer variable, and it gets assigned into this packet buffer, which is then when they do the receive from, it's using packet buffer. So you basically have and then later it goes back to using pointer. Because of that aliasing, CodeQL may not be able to track the taint of like pointer and packet buffer being exactly the same when they're accessed after the fact, but you're matching it after that alias happened. So if this receive from happened before the packet got assigned into buffer, then I'm pretty sure it would match there. But going in this direction, they raise point that it may not be able to match it, and they go into actually something that was new to me for trying to match some of the taint steps here. But yeah, some interesting insight there. I actually learned something out of this, but I'm not sure if that first query quite does what they think. Could also just be my own misunderstanding of some CodeQL stuff, so leave that. And lastly, they have a tool that looks interesting. I haven't played around with it at all yet. They're presenting it at Black Hat Asia. Is this code variant? It's for visualizing the different variants or the different paths that come up from a CodeQL. So this is being built. Have your CodeQL query, and then you have this kind of visualization of the query results.
Yeah, this looks like a really cool tool.
Yeah, it looks interesting. I'd want to play around with it to get a real feel for how useful it is, but to be able to see some of the paths and kind of visualize or remove some of the duplicates and get that visualization seems really interesting.
Yeah, because I mean, trying to track the relationships between like the paths and the calls like that is just really difficult to do from a text-only interface. Um, it's actually something that I've kind of struggled with, and I've had to pull up something stupid like Paint or something to try to, or maybe like ASCII art just to try to map it out visually. So yeah, I think this tool, it looks pretty promising, and I'll probably check it out. Give it
Yeah,
a look.
seems cool. So at least calling it out here. Like I said, I just found out about from this post, so I have not played around with it at all yet. But definitely looks interesting, and I always like seeing CodeQL getting used.
Yeah, it's always nice to see posts that talk about CodeQL because they're there's not a ton of them out there, and it is kind of tricky to use. It has a pretty steep learning curve, so being able to see the queries and seeing them broken down uh, could be very useful to anyone who's interested in using it out there.
Yeah.
All right, so for our last post, we have a Diary of a Reverse Engineer, or Dory post on exploiting two vulnerabilities in Netgear and TP-Link routers, which was submitted to Pwn2Own last year. Post goes into some interesting background info on the target and how they got a debug environment set up, getting a root shell through UART so that they could debug and look around and enumerate the attack surface and stuff. After enumerating the attack surface and chasing down a few dead ends, they ended up discovering two sockets that were listening that had no process name associated with them, which they thought was pretty weird. And after doing some digging into it, they discovered that that was because the sockets were directly bound to this net USB kernel module for doing USB over IP, which is interesting. Um, and it's also a module that gets shipped on multiple devices. So, fairly good target to look at there. So they got to work reversing the driver. They ended up finding a integer overflow in this software bus dispatch normal EP message out function, which seems to be like this main dispatch routine, which takes an opcode and will have handlers set up and whatnot. The first int overflow they detail here was found in this call to malloc page buff. And you can, oh, sorry, I think I jumped to the wrong one here.
Yeah,
But
I've
yeah,
got the right
this
one up on screen though.
Okay, cool. So yeah, this malloc page buff call, you can kind of see there, this v64.0 is a user controlled length, and then they add 9 to it when they call it. Fairly straightforward integer overflow there. Exploit scenario turned out to be a bit interesting though, because this allocation through this malloc page buff is actually using the page or buddy allocator. So it's not using like the kmalloc caches, which are like your more typical exploit route, or your more typical memory corruption point, I should say. There was also no KSLR in play here, and the kernel was configured to survive through panics. So like panic on oops was not set. So you could kind of get away with a few failed exploit attempts or whatever, and it wouldn't crash right away. Though you are introducing instability into the device, but that's kind of beside the point. Um, but yeah, they could kind of cheat a little bit there. Unfortunately, that first bug, they couldn't really get an exploit to work out. Um, they attempted a strategy that Andrei Konovalov described with packet sockets a little while back, which I think we covered on the podcast actually. Um, and that was basically trying to get the kmalloc 1024 cache to take a page that was adjacent to the one they could overflow. That way they could try to, get some memory corruption inside of the kmalloc cache, which is going to have a lot of interesting and useful objects for deriving exploit primitives. Unfortunately, though, they just didn't manage to get it to work. For whatever reason, they couldn't seem to get a page allocated that would go to the kmalloc cache. So they just kind of moved on, wanted to see if they could find a different bug, which they did. They found a second integer overflow in the same function. This one was in the opcode handler for opcode hex 50. They don't really say what that is, but that's not really relevant for the issue. Um, and basically the exact same problem. It would take a received size and then call it to kmalloc, adding 17 to the size, and there was no verification to make sure it didn't overflow. Um, bit interesting here because this one was a bit more useful. It was directly allocating into the kmalloc caches. They say that they were able to allocate into kmalloc 128, which I'm not totally sure why that happens. Because like with the int overflow they have here, they should only be able to allocate or pass like 0 to 16 to kmalloc. Um, I'm guessing it's some kind of thing where because it's an IoT device, the kernel might be configured or MM might be configured to have 128 as the smallest cache. That said, I'm not 100% certain on that. I'm just kind of speculating there.
Yeah,
But
it stood out to me too. I saw that, I'm like, well, you're overflowing just like 0 to 16. Where's 128 coming from? Could be that he always ends at the end of a page and like overflows into the next page or something too. I mean, there's so many things it could be. I'll just take him at his word. I mean, he's the one that wrote the exploit. He's overflowing KMalloc 128, and kind of leave it with that, really. Um, but it did stand out to me as like I'm not exactly sure why that is.
yeah, after tinkering around with it, seeing what they could do, they found if they waited a little bit between the allocation of the buffer they were overflowing and actually sending the data to overflow, they would end up corrupting a quote interesting structure that contained a wait queue head pointer or a next pointer. They didn't really look into how that ended up getting allocated there or what exactly it is.
No, they did say it would be magically allocated, so clearly
Yeah,
invoking magic.
yeah, they just kind of hand wave it. But since this seemed to happen fairly consistently, like, yeah, they just rolled with it. From there, they were able to craft a fake wait queue entry, which is quite an interesting structure from an exploitation perspective in the Linux kernel, because it has a function pointer. So they were able to just corrupt that function pointer to hijack code execution. Reliability was okay-ish, at about 60% in QEMU environment, not super high, and unfortunately, it did seem to end up making it so their exploit didn't land in the 3 attempts given at Pwn2Own. And they were a bit constrained too there because Pwn2Own was fully remote, so they had to provide exploits and documentation prior, um, and they couldn't really do any last-minute adjustments, which was also a bit of a problem because there was a firmware update push for TP-Link after they'd received confirmation from CDI. So that could have been potentially a factor as well. They said that they looked at the update and the hash of the NetUSB module was the same, so that module didn't seem to have changed. So it's not like their bug got patched or something. Um, but what I'm assuming happened here is their exploit strategy was a little brittle, just relying on this object that had a wait queue had T field in it, and just relying on the heap state like that. What I'm assuming might have happened is this update, even though it didn't touch the NetUSB module directly, whatever else it did ended up influencing the program enough to change the assumptions they made about the heap state. So that probably broke their exploit strategy. That's
Yeah,
kind of what I'm guessing is happening here, but
there's a
it's
lot that
hard to
could
tell without
happen.
digging into it. Yeah.
I don't recall if I heard you mention there was no kernel ASLR or NX on this. Um, if you didn't mention that, so they were basically just able to use some of the things they reverse engineered to allocate and get their data into a pretty consistent location. Um, which actually might be another place their exploit broke because I believe they just hard coded this address. So it's possible that with the new system, how that ended up getting allocated, there might have been something else in there. So then it was maybe pushed a little bit later, a little bit earlier, just out of order, leading to that address breaking on them too. There are a number of places where it could have broke. I'm hoping they'll actually look into it, especially if it didn't. Well, I guess they've burned the exploit now, so maybe we won't find out. But would be interesting to know why it broke because that is an aspect we don't often talk about, like the portability of exploits across different machines. It's, well, worked on my machine, so good enough. And sometimes the exploit strategies can work with that because, like, they're taking into account a lot of things or being able to figure out what was actually corrupted, whatever. And in this case, what been interesting to get a little bit of that information.
Yeah. Um, Maybe somebody could look into it, like if they could find like old updates or whatever, and I think this would be cool to do some root causing on to try to make it more portable. But yeah, they don't really talk about that in the blog post. Um, s- Overall,
Seems
even
like an
though they didn't,
annoying device to actually kind of go and do that with, though.
it is a you do need a bit of a setup to get into it and be able to do debugging and stuff. So yeah, that's a fair point. But I still think it would be cool to do some root causing there. But yeah, even though they didn't get this working at Pwn2Own, still some cool bugs nonetheless. Some interesting exploit details going on there. They kind of said in the post that they didn't expect to be looking at like the kernel as their entry point for trying to attack the router, but that was where it ended up going. But they said if they revisit this target in the future, they'll probably avoid the kernel and go for something a bit more easier to predict, I guess, and
But
not have to
binary
worry
is
about
more
some of the
fun.
portability stuff. That's true. I mean,
So I want to bring up one thing. They mentioned at the top of this, they were looking at, I think, UHTTPD. And I thought it was really interesting. They mentioned that it will call out into Lua extensions. And that basically the existing Lua tooling didn't work because the Lua runtime on device had shuffled their opcodes. It just sounds like a really absurd, like, mitigation to have been put in place, because it does feel intentional. I don't think it's accidental that the opcodes got shuffled, but it also seems like a really stupid thing. Like, yes, it makes it a little bit more difficult, and is almost an example here of how security by obscurity has some benefit. It indicates, like, yeah, you went through a bit of the reverse engineering and decided to go look a little bit elsewhere rather than carrying on with uh looking in at that area. Although he does say he managed to decompile it, so it wasn't actually effective. But it's one of those stupid things that companies do. Makes it a little bit harder on the researchers, but doesn't really add any security. Like, you can
yeah, it
see
just
how,
makes it annoying.
yeah, and you can see how that in effect did turn them away from that component to look elsewhere, but it doesn't make them any more secure, so it's not something to rely upon. I was just surprised to see that, because it really feels like one of those things somebody just thought up, and they're just came up with and added it in there without, really just saying about making it hard for the researchers, but attackers can spend more time on it than most researchers can. So
Yeah, that's kind of been the argument with a lot of these security through obscurity type things, is like it hurts researchers more than dedicated attackers. Um, and yeah, I think this is the technique they straight up just borrowed from Windows. Like, this is basically what Windows does with like their syscall tables and syscall numbering. So it seems like they looked at that and were like, oh, we'll do that too. So
I don't know. So in
um,
Windows, like, it adds a little bit of a challenge to the portability of exploits.
yeah,
Um, but it's not all that hidden what, like, the opcodes are and stuff. I suppose it's maybe not that hidden in this case either. Like, you can reverse engineer it, but um I mean, Windows is just kind of developed so you don't do the direct syscalls anyhow, and that gives them a little bit of flexibility. So I can see an engineering reason behind that choice, not just trying to ruin it for exploit devs. On the Windows aspect, that is. In fact, that they've probably been doing that longer than security's really been the main concern.
yeah. But yeah, like as Z is kind of pointing out here, there's a few like interesting nuggets in this post. Um, that kind of stand out and bring up some interesting discussion points. Um, and
Honestly,
yeah,
when I
that's why I
see,
like the Dory post so much.
yeah, and I like his blog on a whole. But when I see things like that being introduced as a mitigation, it makes me think that I can't think of the right way to really phrase this, or at least to phrase it eloquently. But it just makes me think they're trying to gloss over or hide the really obvious and really bad bugs by doing these other crazy things rather than just following proper engineering practices. Like that's what I think when I see these things. Obviously, maybe they're also doing really great engineering down there, but when I see those sorts of things, I immediately start thinking probably not.
Yeah, you kind of take it as like an encouraging observation, basically.
Yeah,
Yeah, and Obfly in chat said those Lua scripts on network devices are usually full of command injection bugs.
we've covered quite
Yeah,
a few, I think.
we covered quite a few even yesterday, I believe. So doesn't surprise me at
Well,
all.
not Lua, but
No, not Lua, sorry, but just command injection bugs in general. Seems really easy to have those types of bugs in that type of attack surface. So, but yeah, unless you have any last minute thoughts, C, we'll go ahead and wrap up the episode because that's all the topics we have for today.
Yeah, no shoutouts, but I guess I will also say, and if I mentioned it, but the exploit script here did look pretty nice. It was very prettified,
You
at
gotta
least in
have
the
nice looking exploits.
visualization of it.
Yeah. But yeah, like I said, that's everything that we have for today. Thank you, everyone who tuned in. VOD will be up on YouTube and Spotify and other platforms tomorrow, as always. Remember to follow our Twitter and join our Discord to join the community. Links for that are on our website or in chat. Other than that, though, we'll be back next week. And until then, take care.